Welcome to a new test and teardown video. This time it's a compressor limiter from Furman Sound called LC2 limiter compressor. I was told this unit should work, but they didn't like the sound quality of this unit, so I kind of just got it. As far as I know, this should be a mono, a single channel unit, and what this will do is it will monitor the input level, and you can set here the input level to the unit. So if you crank up this input level and down with the output level, this way you remain the same kind of level, so it's not amplifying, but this means it's going to the point where it attacks and where it is doing compression will be adjustable by combining the two input and output pots. So that will be the attack time in milliseconds and release time, and then how much compression ratio do you want? How aggressive do you want this to compress? So you can have this in limit or in compress. A limit is just a cutoff, and a compress is a gain reduction. So it depends on what you want. You can also have this at DS, so that is it attacks higher frequencies better or faster. And side chain, I'll have to show you the rear panel so you will see what side chain is. So here we go with the rear panel, and look at that. This is of course updated, so it runs off 230, but and there was some sort of a sticker over this, if I'm not wrong. I really hate it when this is not updated, when this unit is rewired for another voltage, by the way. So input and output is a single channel. Side chain input and side chain output, that is when this unit detects a limit factor, and it will send an output to the other channels. If you want stereo, you need two of these. So this way you connect these two units together with either a stereo link or a separate input-output side chain cable. So that means both of the channels will be limited or compressed equally, and the signal that was on the input of the audio line that made this happen will affect both channels equally. So that is the idea about this. So we're inside, and exactly what I said. Single channel inputs, only one wire to each of the jack, and all those wires just non-shielded wires. This is good for crosstalk, but that is of course not a problem. This is not a studio grade equipment. Transformer is wired for 230. You see the two windings here, they're in series. And then there's a really nice fuse. I don't see any regulators on the supply. Just some diodes and those caps, and that is it. And it's because the op amps, they got a very, very high power supply rejection ratio, and this means it doesn't really matter if there's ripple on the power supplies. You shouldn't have any hum or ripple on the outside, actually. So it's just a lot of op amps doing all its things. I'll go and have a little look on the date codes here if I can figure this out. Maybe this is from the, hang on, this is 8117, right? And here's 8050. I mean, it could definitely be 80s. Oh, it says 81 on the IC codes. Yeah, so this thing is from 81. How about we try and power this up and see if it works? It's actually real hard to make a setup to show you what a compressor limiter is doing. But here is a 1 kilohertz 600 millivolt RMS input. So this is the input, this is the output, and this is the side chain output from this unit. At the moment, this is my compression ratio. It's all the way down. And as you see here on those 5 LEDs, that is a very essential adjustments or indications for adjustments what is going on, and that is gain reduction. This will tell you if it's operating correctly. So let's play a little bit with the input level knob here. See, input level affects, of course, as you see here, the output level, right? And also the side chain. So that will be the input. And of course, I want the same output level. That is the channel 2 here, right? So that will be output level here, right? Of course, I want input and output to be the same. Okay? Then I play with compression ratio. If I crank up, ooh, you see what happens? When I crank up compression ratio, it attenuates my output and it keeps my output, see, like this. Now we have a compression ratio of -4 dB. Okay, so what happens if I input some more signal from my signal generator? What's going to happen with the output and also the gain reduction? So have a look at this. Now I play with the input. See, more and more input. And output is very, very constant. And you see here we get more and more gain reduction. So we can say here by this compression ratio how aggressive we want this to be. Oh, now we don't want it to be super. Oh, there's a little bit of noise in this pot. So now we don't want it to be super aggressive. That means it's going to be a little bit of a, like the limit point is a little bit elastic. So have a look now. I have a much lower compression ratio. Now let's play a little bit with the input again, see? Now output follows input. Of course it is gain reduced, but it's not as aggressive. So this is the aggressive factor. See? Here we go, absolutely crazy. So yeah, that is what a compressor is doing. And I think it is, I really don't like the idea with the input and output. Most of them, they work this way, but it's annoying from a user perspective where you need to play with the input and the output to get the same level and then to find the point. I mean, if you have audio here and you're listening to the material, it's not that difficult really to figure this out, because when it is compressed like this, for example, now it's really aggressive. Of course, you want the output to hit your 0 VU, right? So this is probably that. Then you can hit that spot, and then it's not. See, come with more. You're not gonna overdrive something, and you're still able to hear what it is the material is. So let's play with the attack and release. So I put attack for 5 milliseconds, and we got 5 milliseconds per division here. And I am in single trigger mode. Now I enable input. And now you see, because we have an attack time, we got gain. We have set up the system for gain, but it is reducing the gain due to compression settings, right? So this is what you see here. That will be the attack time. So now I turn down the attack time to its 0.4 milliseconds, and then we try and redo this test. See, now it's super fast. We can of course do the same with we can of course do the same for release time. I don't think it is super visible to see exactly what's going on here. So this is the input where I'm doing a step level, and look at the output here. That will be the attack, and that will be the release, where I gain up quite slowly, right? And then we can play with the release time. Now we'll crank down release time, so it should be a lot faster. Let me do it as fast as I can with both of them, right? See, now there's no Isn't that funny to see? The output level is constant, but input level is jumping like that, right? And then we crank on some release and attack, and then we see how it looks like. Replacing all those LEDs, that was definitely necessary. They're super dim, and we need new and modern LEDs in. And this is what I would call a lazy man's repair job. I'm probably going to hell for this. I should of course not tell you how to do super lazy man's solutions, but if you just cut the pins to the old LEDs, bend them a little bit out, pull out the old LED, in with a new one, cut and solder like this, and bada bing bada bum, you're done real fast and real cheap, and this way you'll save your customers a lot of money. So that is with new LEDs installed. Look at that. Oh, they are powerful. You can really see what you're doing. An overload indication. Now it's visible. Before they were so dim you couldn't even see anything. You really need to see this from a big distance. Well, you can also see the release time when I turned off input. Alright, thank you very much for watching. I hope you enjoyed this little limiter compressor walkthrough. Hope to see you again, maybe tomorrow.